All right, calculus students, since I'm going to be gone Wednesday, Thursday, and Friday on Oahu for conferences, I'm going to give something new a try, which is this software. And what I plan on doing is going through section 2.5 and having you watch the lessons in the evening and then working on the homework during the day in class on Wednesday and Friday. And hopefully if you watch the videos and you work together, you'll be able to get most, if not all, of the homework done by Friday, so you don't have any homework over the weekend. Yay, hopefully. That's the goal. All right, so let's get started. Section 2.5 is on differentiation of implicit equations. Kind of in short, it's called implicit differentiation, but I'd rather you know it as differentiation of implicit equations. And before we get into what implicit equations are, let's review just some basic derivatives. So if I take the derivative with respect to x of x squared, I want you to notice that the variable that we're taking the derivative of is x, and the derivative that we're taking the derivative with respect to x. So these are the same. My bad handwriting is even worse on this software. All right, well, let's deal with it. All right, so anyway, so we've got the derivative of x squared. So x is the same as the dx. And so if you take the derivative of x squared, that's just equal to 2x. But let's do it where the variables are different. So let's say we take the derivative with respect to x of u squared. Now here we're going to have to use the chain rule. And notice that the variable that I'm taking the derivative of and the variable I'm taking the derivative with respect to are different. And if these are different, then I'm going to have to use the chain rule. And so I'm going to use the chain power rule in this case. And so if I do so, I get 2 times u, u to the first, times u prime. And that's the chain. Now, this u prime, I'm going to write it a little bit differently. This u prime is really, so 2u and then times u prime. U prime is really du dx. Now, I want you to notice that when I'm looking at this u prime and I redefine it as du dx, that over here I've got u du dx, and over on the left-hand side, I've got this u and this x. And so when you're using the chain rule, and you've got different variables, you take the derivative like you normally would, but then you've got to multiply it by the chain, which in this case would be du dx. Now let's go back up here, where I just have the derivative of x squared. Technically, we're doing the same thing. We didn't actually say it before, and the reason why is because learning derivatives rules was confusing enough. But technically speaking, we use the chain rule with this top one as well. So if I take the derivative with respect to x of x squared, I'm just going to go ahead and write over this. It's going to be 2x, but then times x prime. But x prime is going to be dx dx. And dx is just 1, and so that's why we write it as just 2x. But technically speaking, you're taking the chain rule whenever you're using the chain rule whenever you're taking derivatives. Okay, let's do another one. So let's do the derivative d dx of y cubed. Now notice here that the variables are different. And if the variables are different, then I definitely have to use the chain rule. So the derivative with respect to x of y cubed is going to be 3y squared times y prime. And in this section, those y primes I really want to write as dy dx. So I've got 3y squared times dy dx. Let's go ahead and do one more. So let's say I have d dq of p to the fourth. All right, so I'm taking the derivative of p with respect to q. And so even though the variables are different, what you want to do is just take the derivative of p like you normally would. So that would be 4 times p to the third power using the power rule. But then we have to multiply it by the chain, p prime. And so in this chapter, I want to write this as 4p cubed times p prime is going to be dp dq. So if I look back over here, here's the P and here's your Q. And so you take the derivative of what's inside, like you normally would, but then you've got to multiply it by dP dQ. Let's do one more. So let's say I want to take the derivative with respect to x of sine of y. All right, well, I know the rule, the chain rule for sine of y, and actually I'm going to go and put it up here. So the derivative with respect to x of sine of u is going to be equal to cosine of u times u prime. So over here, the derivative of sine of y is going to be cosine of y times the derivative of y with respect to x. And the derivative of y with respect to x is going to be 1 times dy dx. And so using the chain rule, the derivative of sine of y is going to be cosine of y times y prime, which is dy dx. Okay, so this kind of sets us up for what we're going to be doing in this chapter. I'm going to go ahead and erase all of this. And I'm going to point out a couple other things before we actually start with implicit differentiation. I'm sure there's an easier way to clear out the page. I haven't figured it out. Okay, so let's go back and look at something simple, like y is equal to x to the fourth plus cosine of x. Now I know that when I take the derivative of this, I know that I get dy dx is equal to 4x cubed, and then the derivative of cosine of x is minus sine of x. And this is something you know already, but I want you to look at this in a completely different way, and this is really important for the rest of the class actually, is let's start with our original equation. So I'm going to rewrite this as y is equal to x to the fourth plus cosine of x. And I want to find dy dx. Okay, what I'm actually doing here, and this is something we haven't done before because, again, learning the basic rules of differentiation was confusing enough. But what we want to do here is I want to actually take, when I'm taking the derivative, take d dx of both sides. So I'm going to take d dx of both sides. So when I do so, I'm going to take d dx of the left-hand side, which is just y, and I'm going to take d dx of the right-hand side, which is x to the fourth plus cosine of x. All right, let's deal with the right-hand side first. So this right-hand side, I can distribute the derivative for sums and differences, never for quotients or products. And what I can do is, because the variables are same, so same, they're both x's, then I'm technically using the chain rule, but I don't actually have to write it out. But I will write it out this one time. So I take the derivative of x to the fourth with respect to x. I get 4x cubed times the chain, which is dx. Plus, if I take the derivative of cosine of x with respect to x, I get minus sine of x times dx. Now dx is 1, and so that's why we never write it. But technically that chain is still there. Now look at the the left-hand side. The left-hand side, back up here, is we've got the derivative of y with respect to x. Now what's the derivative of just y? Well, that's y to the first power. And so the derivative of y is just 1. But we have to multiply that 1 by the chain, which is dy dx. And so that's actually where we get the dy dx when we're taking derivatives, because we're taking the derivative with respect to x of both sides. And so if I kind of get rid of these 1's, then I get dy dx is equal to 4x cubed minus sine of x. So this is how I want you to look at derivatives from now on, is that when you're taking the derivative of a function, y equals, you're actually taking d dx of both sides. And we'll see where this is useful in the next parts of the video. All right.